There once was a ship that put to sea. The name of the ship was the Billy of Tea. The winds blew hard, her bow dipped down. Blow, my bully boys, blow. Soon may the wellerman come to bring us sugar and tea and rum. One day when the tonguing is done, we'll take our leave and go. She had not been 2 weeks from shore when down on her a right whale bore. The captain called all hands and swore he'd take that whale in tow. Soon may the wellerman come to bring us sugar and tea and rum. One day when the tonguing is done, we'll take our leave and go.
All right, welcome back, everybody. It feels like it's been quite some time since we were last in lecture together, given the recent quiz, the wellness days, the snow day, but it's great to be back with you today. We've got a warm-up poll going with hopefully a pretty straightforward question to get us started with. I'll come back to that in just a little bit. But the link is, as usual, polllab.com/COMP110 for the synchronous section, and then for the asynchronous section, the link is on the slide deck. We've got an exciting lecture today, a number of topics that we'll introduce that are really the fundamental superpowers of computing. The first is more of a syntactical improvement that's a minor concept that will help us write more succinct code with the highlights of today's lecture, which are focusing on introducing the concept of lists, where lists give us a means for having variables that can store an arbitrary amount of data in them. And so we'll be able to take on problems that are much larger than the problems we could take on with only variables. The sort of other half, the yin to the yang of lists, is loops. And loops are going to give us the ability to write code that has repetition in it. And so what we'll see with the repetition is that we can process arbitrary amounts of data stored in our lists by writing specifically constructed loops. Right? We'll get started with relative reassignment. Like I said, that's a minor subject and won't take us long to cover, and I think you'll be able to master that very quickly. A few quick announcements before we get into the primary focus of today. First, as you all know, the first project of the semester, Project Zero, is a choose your own adventure textual-based game that you'll get to design with whatever criteria or whatever storyline you'd like. And some of the technical specifics are specified on the project write-up. That's going to be due this coming Sunday. And I'm going to encourage you to, if you haven't gotten started on it, to start as early as possible. This is one where you have freedom to decide, what type of game or what type of experience or storyline you might implement. We've done this project in the past and seen some really creative solutions and ideas that were really fun to interact with, and made very clever uses of emoji. Love to see that. For the quiz, the second quiz one of those grades were posted last week, and you all crushed it. It was a very strong performance. I think the median was about an 85, which is a very healthy place to be. Really demonstrates that the effort and time you put into mastering your environment diagrams with functions paid off, and you're in great shape. If you're looking for coverage on some of the questions, like you had some uncertainties about why you got something wrong, if you did, Kaki put together a Zoom talk last Wednesday that was recorded and is available on the website if you look under the February 17th entry. Otherwise, if you have a specific question, come by tutoring any night this evening or any night this week, and including this evening, and we'll work with you one-on-one or in a small group in tutoring. Office hours and tutoring are back to a normal full week. So we had the days off because of the wellness days, but tutoring is tonight, tomorrow, and Thursday as usual. And office hours, especially for questions on this current project, are typical hours, 40 a week. But do expect that as we move closer to the deadline, that the wait times you might expect will significantly increase. And this is one of the reasons why we encourage you to start early. In fact, a TA has been analyzing last semester's data, and the lines in this chart are due dates for various deliverables and projects. We had some bigger projects at the end of last semester and some smaller ones at the beginning. And the y-axis is how long people waited on average on a given day. And what you can see is that when you get closer to due dates, the wait time dramatically increases because more people are looking for help closer to the deadline. So starting early will help you. All right, so our warm-up question, I'll give you all one more minute here to respond. And it's asking about if you have a string value stored in a variable named a_stir, a_stir, how do you access the very last character of this string? Right? So 30 more seconds on this. Please respond to Poll Everywhere. And if you've already responded, we will be doing some work in VS Code today. So if you want to go ahead and open that up, we'll come back to that in just a little bit. All right, great work on this. 75% of you chose a response that was just about correct, or was correct, and over 50% of you chose the correct option. So accessing specific elements of a string requires careful attention to the syntax that we use. And what we're seeing here is the variable reference at the very beginning, so a_stir at each of these options. And then inside of the parentheses in the first two options or the square brackets in the second two options, we're using the length function, which returns the length of a string, or we'll see today other things as well. And so the length of a string is always 1 greater than the last index of it. And let me open up my pen software real quick. And we can get a visual of what's going on here. So let's imagine a string that had, say the characters ABC in it. And so A, B, and C. Well, we know string indices start out with 0, 1, and 2. They are 0 indexed, we like to say. And this is a reminder because we'll see that when we get to lists, they're very similar in that they're 0 indexed as well. And so even though the length of this string, so the length of a_stir, is 3, right? So because the length is 3, if we want to access the last element of it, which would be, this C character at index 2, what we're going to have to do is subtract 1 from the total length, right? And the reason we do this is because of this funny business about starting with 0, which we'll talk about later. But we know that if we want to access the very first character of a string, you would access index 0. Right? So this gives us the index, which in this case would evaluate to 2. And then the question is, well, which of the other syntaxes is correct? So a_stir. And then there's a question of, do we use parentheses or square brackets? And I'm happy to report that the majority of you got it correct in that you're looking for the square brackets. When we use what's called subscription notation, both of these options, we're using subscription notation. That means we're accessing some specific item within a string here by its index. And the square brackets are the syntactical hint that you're doing this type of an indexing. All right, let me check and see if there are any questions that have come in. So one question that's come in is, will there be extra credit if the project is turned in early? Yes, on some of the auto-graded on the auto-graded portions of this project, there is extra credit. The same percentage is applied to it because there will be a significant part of this project which is manually graded by our team because this is a very custom project. Everyone has a unique solution to it. We can't do extra credit on that portion of it, but there is extra credit for getting it in early. All right, let me see if there are other questions. Can you bring questions about the project to tutoring and office hours? So when it comes to a project, if you want to talk in broad terms about concepts that you might need on a project or things like that, tutoring is fine. But when it comes to like if it's something that someone would need to look at your code, or you would need to explain lines of your code line by line, do come to office hours for those with those questions. How many projects will there be this semester? Probably about 2 or 3 more after this one. So 3 or 4 is what we're aiming for. It's going to depend a little bit on how things progress. We've got some new content planned in the second half of the semester. So it's one idea we have in mind, which is analyzing some data from police traffic stops, is either going to be like a series of exercises or a project. And we're still trying to decide which way to go with that. All right, great work on this. I'll come back to questions after we talk about some of the first concepts. So the first concept we're going to take a look at today is the idea of relative reassignment. And this is a relatively minor improvement over what we know currently. It doesn't give us any new capabilities, but it is really handy to know about. So the idea is there's very frequently, you're going to have statements that look something like this, right? X is assigned X plus 1. And what we're doing in a statement like this is we're reassigning the X variable's value, assume it's an integer, to be whatever it currently is plus 1. So we're reassigning X relative to its current value. So because assigning a variable based on its current value is very common. So common, in fact, there's a shorthand for it. So let's show you that shorthand. And the shorthand operators, there are shorthand operators. So let's imagine we've got this X is assigned X plus 1. This is the same as, equivalent to, X, and then the relative reassignment operator is plus equals 1. All right. So what you're going to notice is the pattern when we're looking at these operators is that they form statements that are assignment statements, just like what we're seeing on the left, right? But the key difference is when you see like what we think of as a binary operator, something that takes 2 values. So X plus 1, X minus 1, X multiplied by 3, things like that. And we put it in front of the assignment operator like this. It has the effect, or the semantics of this are the exact same as if you had written the assignment on the left. So we can say, same as what's on the left, right? And you might be thinking, well, that doesn't seem like too much of an improvement. Well, when we start using variable names that are a little bit longer, so let's imagine, you can do this with strings and concatenation as well. But let's imagine we had something like a balance variable. So balance, and maybe there's some balance is assigned balance times 1.2, like 20% of an increase in our balance is what we're reassigning some balance variable with. Well, as our variable names get longer, it does become a little bit more tedious to have to type them out multiple times in a line. And there are places where you might want to do this on multiple lines in a row. So here we would be able to say something like, balance multiply equal 1.2. And these two things have the same ramifications, right? So it's the exact same thing. All right. One of the questions that just came in is there any white space, or is there any spacing between, these two characters or these two characters? No, these are right up on top of one another. There's no space between them. And that's important. You would have a syntax error if there was a space between them. Great question. All right. There are 2 questions related to the opening, the challenge problem. I'll come back to those when we get to lists because we'll have very similar concerns there. All right. So this is the relative reassignment operator, and where it's going to be handy, what we're going to see when we're writing loops and when we're working with lists, it's very frequent that we are trying to, maybe we're adding up all the values in some list, we're summing a list, and we would have some accumulating variable that we continue to add to, that's our sum. We'll see that we'll use it there. Additionally, when we're looping, we're going to be counting with some counter variable, and we're just going to be typically increasing that by 1 or decreasing that by 1. I should note that this works with other operators as well, so not just the plus or the addition operator, but subtraction, multiplication. Even with Boolean variables, you can use this with the and an or. And so it's a very powerful shorthand syntax. That's really all there is to say about relative reassignment. I just wanted to mention it because you'll see this in some of the code listings that we do today. Lists are one of the most powerful data structures, which is a concept we'll learn more about, that we'll have in our repertoire by the end of this course. And the idea should have some familiarity associated with it. You've used lists throughout your life. When you number some list of things in a document, when you list the things that you need to do in a given day, when you list out when you're keeping track of some, maybe you're rolling some dice and trying to keep track of what numbers you've rolled in a game. There are many places where we like to think of things as being organized in a list, where items in our list are ordered specifically within it. And we can arbitrarily add to a list or remove from a list. And we're going to see that in Python, as with in many other programming languages, we have lists at our disposal. So let's just talk a little bit about lists at an intuitive level, and then go do an interactive programming exercise together with them. All right, so I'm going to jump to a blank screen here, and let's just jot down some of the big ideas. So the first thing that we need to know when we're working with a new data type is, what is the type, right? And the type of a list is typically a list of some other type, like a list of strings, a list of integers, or a list of Booleans, a list of any other type, but it's a list of some other type. So if we want to imagine what this looks like, let's imagine we have a variable and we're keeping track of rolls of a die. And we are going to type this list with a list of, say, integers. All right, so a list and then square bracket int. And what this type is saying is that rolls is going to be a list of ints. More generally, you'll notice that we have a list, and if I were to substitute just a sort of a generic T here, or a capital T, we would say this is a list of any type T. And we call that sort of a generic type. We don't specifically know what T is, but we can have a list of any other type, right? In this example that we're moving through currently, we're talking about a list of integers. And you can kind of get that sense by saying we've got a list, which is the container or the data structure type. And then we're specifically saying, but it's more concretely a list of integers, right? One of the questions that came up earlier was, do we have to type our variables in this way? So this is us declaring a variable and offering a concrete type. And the question said, in Java, we have to do this, but I didn't think that was a Python thing. In Python, in more modern variants of Python, more modern versions, so starting with version 3.6, and we're currently on 3.9, this idea of type hinting, or what we call static type declarations, was added to the language, and it's increasing in popularity. And the reason why we go to this trouble of specifically and concretely typing our variables and our parameters and our return types and those various things is because it will offer us a way of checking over our back and making sure that if we actually accidentally made logical errors somewhere in our code and tried to use one variable as a type that it wasn't, like if we tried to use rolls as just a plain integer, we would get an error by being more specific and concrete about our types. And so by practicing this in Python and in the context that we are, it will help transfer this knowledge to any other programming language you learn. So this is considered a best practice in modern software engineering. And if you were to go and look at, if someone was trying to write a quick little script, you might not type it this specifically. And you might see Python that doesn't involve any types at all, but it is a best practice, and increasingly so with the more modern versions of Python. All right, so that's the type of a list, how do we actually specify the items of a list? Well, what we'd like to be able to say is roles is assigned and then a list of integers, right? So let's say we rolled a 2 and we rolled a 3 and maybe we rolled another 2 and maybe a 6, right? And that feels very natural. Well, for this to have meaning as a list in Python, we need to use what's called list literal syntax. And so this is a list literal expression. If we just put the square brackets around these items, then we are specifying a list literal. So this is a list literal expression. Right? And so this is assigning a list whose items are 2, 3, 2, 6 to the variable roles. What we're going to do is surround initial items in square brackets. And I want to make a note that if you had an empty list, so if you had a list with nothing in it, if you just put an empty set of square brackets in the correct position, this is an empty list, and that's okay too. Right? So the idea is we can make a literal that's an expression. So we can use this kind of a literal anywhere we expect a list of integers. In this case, assigning it to the roles variable. And all you've got to do is list out your initial items separated by commas and put some square brackets around it. That's the syntax in Python. If we had a list of strings, you could imagine hello and world. Same idea. We could have a list of strings just the same. Again, integers, strings, we can store any kind of data inside of a list. That's what makes it a generic data structure. All right, so let me clear this out. So next we probably need to know, well, okay, we've got a list. How do we access something inside of it? And you've already seen this syntax before. So I'm going to label this list item access. So let's imagine we wanted to print the first item of this list. Well, we can print roles. And then here's where we see the subscription notation, index 0, say. And the subscription notation is exactly the same as it works exactly the same as it does for strings. So you've actually already seen this before, and the same ideas apply. What this would print out is the number 2. What roles index 0 is referencing is this first item in our list roles, right? So what I want to make a quick note of here is that indexing is 0 based. And it uses subscription operator. All right. So subscription is the idea of trying to access a very specific element within a sequence. In this case, it's within the roles list, right? But we saw even in the opening example, you can access individual characters within a string very similarly, right? Just like with a string, it's good to be able to know how many items are in a given list, because these lists are going to be able to be arbitrarily long. This list's length is 4. It has 4 items in it, but you can imagine a list with hundreds, thousands, or millions of items in them as well. So when we go to write algorithms, we're going to need to know how many items are in a list. So how do we do that? Well, we can get the length of the list the same way you get it with a string. So the built-in, actually, let me highlight this in green because that's the important bit here. The length of a list is accessed in Python using the built-in function len, right? So this will return to you the length of the list. And one of the questions that came up earlier relative to the very first problem was, why do we subtract 1 from the length of a string, or in this case, it would be the length of a list, in order to access its last element? Well, the reason why is because if these are 0 indexed, 0, 1, 2, 3 are indices, and we ask for the length of this list, like we do here, that would result in a value of 4. but if we ask for roles of index 4, right, roles index 4, we would get an error. There is no item whose index is 4. The highest index is 3 because we start counting from 0. So if we wanted to access the last item of the roles list, we would do the same thing as we did before, length of roles minus 1. Right? And again, using subscription notation. So you subtract 1 for the sort of odd reason that we start from 0, but we'll see why it's very convenient and handy to start from 0 when we talk about loops in just a moment. All right, let me check the questions that we've got going on over here. So one question is, can you put another variable on the other side of a relative operator? So this is going back to the previous set of ideas. Best practice would be not doing that. I'm actually not sure whether you can in Python. I can imagine in some languages you can. You can imagine that working, but I think your best bet is to actually, in fact, in Python specifically, I'm almost certain that would not work. But even if it did, I would encourage you to use the simpler form that's a little bit more expressive. All right. Can we have the user enter a list of their own data into a list? Yes, that's a great question. I love that question. So we will look at how we can append to a list or remove items from a list while the program is running. What this list literal gives you the ability to do, as we'll go try out in VS Code in just a moment, is specify an initial set of values in a list in their given order. But yes, lists are what we call a mutable data type, meaning we can change it or modify it after we've set it up. All right, let me look at. So a question of, how could you have such long lists with character limits in Python? Or is that just for R assignments? The amount of memory that you have in your computer that's available to you in Python is actually quite long or quite significant. Typically, you wouldn't see this all written out on a single line. What would happen is you've got a data file that has maybe all of the measurements, like what we'll do later in the semester, every traffic stop in a number of cities across the United States for the past 20 years. And that's going to be, a list of hundreds of thousands of traffic stops. And those would be stored in a file. And we'll have a program that reads that file and builds up our list as the program's running. It would be very tedious and unexpected to try and populate a list with 100,000 items in it by hand using a list literal. What we'll see is we can build up to that. And actually, I just thought we might be able to populate a list with 1 million different numbers in it by the end of today's lecture. All right. Can you briefly recap when and why we use brackets? Yes. So before we jump into VS Code, I was going to do this after we came back from VS Code. But before we do, let's actually talk about this, because this is a very nuanced question. And there are 3 different places where we're seeing brackets now, and they have different meanings depending on their context. All right, so let's talk about brackets. Three different contexts. All right, so the first is when we're talking about a type, right? So generic data types. So far, we've only seen one of these. We've seen the idea of a list, and we've seen, square brackets here where we put our type of list inside of it, right? So if we have a list that stores integers, we would put int inside of that. But notice this is a data type. List is a type, and then what we're putting in the square brackets is another type. And so if we wanted to specify variables are going to be lists, or parameters are going to be lists, or a return type is going to be a list, you would use this. And maybe that's probably worth making a note on too. So for variables, for var declarations, so var decals for short, parameters, params, and return types. All right. The second place that we will commonly see square brackets, that's an important context, are when we're accessing items, right? So accessing items with subscription. All right. So the subscript notation is, if we wanted to give an example of that, that's like saying we have a variable named roles, and that's where we were using, square brackets here and some int expression. All right. And that integer expression is important. And we're going to see that that's going to be a superpower that we like, the fact that we can write any integer expression when we're accessing specific items from a list or a string or other types of sequences is a superpower. Right. So keep that in mind. That's a foreshadowing of, we're going to use this in a really clever and cool way. We're not going to always be writing specific numbers in here. We'll use variables that are integer values and can have expressions. And the third place is when we are declaring our list literals, right? So list literals. And these are expressions. Right? And so if I used a different color here, let's say pink, this is when we have, an item with 1, 2, 3 in it. So each item of this list is an integer. And this is setting up a new list, right? So notice that this specific syntax is accessing an individual item. So this expression, the type of this expression, would evaluate to whatever roles type was, which would be another integer. But if it were, like, say, a list of words, it might be a string. Whereas this expression, a list literal, its type is going to be, a list of integers. And we'll see that nuance here in VS Code in just a moment. And then the last context was the first one we talked about, which is when we go to type a list. And we'll see some other data types, which use a very similar concept in the future. But for now, a generic data type, the only one we know about is list. All right, that's a great question. These are 3 very, very different uses of square brackets. They each have their nuanced meaning. So it is worth practicing in reviewing and convincing yourself at any place where in our code you see square brackets, you can distinguish which of these 3 uses it is and have some understanding of why they do have different meanings. All right. All right. Question of, could you make a Python program that randomly selects from a list, such as replicating a dice roll? Yes, absolutely. That's one of the most popular ways of implementing games. Magic 8 Ball is a program that you all implemented earlier in the semester. Then once we have lists, you can actually do much more easily and have many more options than having a big nested if then else statement. So we're going to see there's a lot of use cases for this. Let's actually jump into VS Code. I'm going to put a pause on the questions for a moment and just get a few examples in code that you can play around with after lecture. So I'm going to, in my lessons directory, set up a new file and name this, say, list_examples.py. All right. So just in lessons or really wherever you want to put it, but if you want to follow along precisely with what we're doing here, in the lessons directory, setting up a file named list_examples.py. All right. And let's just go ahead and add a doc comment here. So my doc comment is going to be some examples of list concepts. All right. So first, let's just declare a list and let's continue with the example we were using before. So roles is going to be a list of type integer. So I'm going to add a comment here. And so remember, the hashtag symbol allows you to write English comments and anything that we write in English following or in any notation following a hashtag is going to be ignored by Python. So declare a variable whose type is list of integers, right? Now, of course, just like with other variables, we could declare and initialize all on the same line, but for code purposes or for example purposes, I'm going to do these in 2 separate steps. So roles is assigned and I don't know, 2, 3, 2, 6. Let's imagine those were our initial roles, right? Initialize a list literal. Initialized with list literal syntax. All right. Now let's maybe print the very last item of a list. Or let's print the length of the list. And I want to use a concept that you all read about over the weekend and yesterday, which is a format string. So remember, a format string is one that begins with an F preceding the double quotes, the pair of double quotes for a string. And let's say length of roles is, and then in our curly braces. So curly braces is another type of brace. We've got parentheses, which you primarily see for grouping prioritization in precedence in your arithmetic operators or your logical operators, or in making function calls or declaring a function. Square brackets are primarily used in how we've been seeing them with respect to lists or other containers in a few different ways. And curly braces, we see that we're using those here for saying this is part of our template and this is where we're going to substitute some expression in. So we're going to substitute in the length of roles, right? And let's just go ahead and run this to convince ourselves that this is working so far. So I'm going to start up my terminal and save my file. So one of the things to always remember to do is save your work. So notice that whenever I make a change, there's this blue circle or this white circle when we're using this theme that replaces the X. And that is an indicator that you haven't saved your work. So if you see a blue circle anywhere after you're finished working on something, about to go try and run it, be sure to save. I should have said that a long time ago, but one of you actually let me know in the feedback form that I had autosave turned on, which is a feature you can turn on. And I might encourage you to, but for my purposes, I'm not going to turn that on. I do think it's valuable to know, at what point was there a save that happened and did you go and run your program? But if saving is something you find yourself forgetting to do, look for the autosave feature in VS Code through the preferences page. So I'm going to run this program with Python module and lessons.listExamples. And what do you know? This isn't the most exciting program, but the length of our roles list is 4. So this seems to work correctly. It's 4 because there are 4 items in it. All right. I want to show you 2 other features of a list before we change gears to look at loops, and then we'll come back and bring both of these concepts together. So there's a question of, can we add things to a list? Well, what if we imported, so from random, import randint, right? So the randint function is one that will generate a random integer for us between some bounds. So what if we wanted to append another random role to our list of roles to keep track of what were the things that we've rolled if we imagine rolling a die? So we could say roles.append, and this is a method, randint, and between 1 and 6, right? So great, we've got another random number appended to our list of roles. So this is something that's important about a list. We can add new elements to the end of it, and it's no problem. And you'll hear me use the words elements or items as part of like the individual values inside of a list. And those two words are interchangeable. Elements, items, values in a list, all synonymous with one another. Okay, if we want to convince ourselves that we actually got a random item added here, I could go and print this, all right? One of the things I'll mention is if for some reason you're having trouble following along with an example, you're getting an error, I'm not going to be able to answer those questions through Poll Everywhere, but if you want to jump into tutoring right after lecture, that's a great place to go over anything that might have gone wrong while you were trying to follow the examples. So I ran this program and noticed that length of roles is 4, and then the very last item was 1. Yours is probably, has a 1 in 6 chance of being 1. If I ran this again, we would see that the last item was 3, because we're appending a random integer to our list. So hopefully you're starting to get the sense that it's kind of powerful and neat that we can add new items to the ends of our lists. And this gets to, how could you have a list with 1 million items in it? Well, we just need to figure out a way of adding 1 million items to it through an append method call. It's been a while since we've talked about methods, and we still don't know exactly how they work. But when you're trying to add items on to the end of a list, this syntax that you see here, the name of the list followed by a dot and then append, And then what looks like a function call is what makes up, a method call. And what we're saying is I want to the roles list, I want to append, and then whatever this argument value is what gets appended. All right, so append just means add a new item onto the end of a list. And so this is now the items of our list after we've done that. Can lists store other lists? That's a great question. And the answer is yes. We won't see that for a while, but you can have what we call 2D lists. And this is if you're making like a game like Battleship or checkers or chess, having a 2D list where you've got a list of your rows and a list of the columns within that row, or vice versa, is how you would go about it. It would be a list of lists, and that's how you get a 2D grid of values is one way of thinking about it. And you can have lists within lists as well. We'll come back to that later in the semester. I don't want to worry too much about that here. All right. Does append apply to the last item in the list, or you can put a new item anywhere? For our purposes right now, we're going to assume a more primitive set of operations, meaning a simpler, more restricted set. And you should think of append as only going at the end of a list. There are ways of inserting in the middle that we'll learn about later. But for a list, that actually winds up being pretty expensive, because in order to do that, behind the scenes, everything that comes after that item has to be shifted by one and moved in memory by the computer in order to carry that out. So append is a very fast operation. It just adds something onto the end of a list, and nothing else needs to be rearranged in front of it. All right. Why wouldn't length of roles be 3? Well, because we had 1, 2, 3, and then the 4 values there. I want to note that in a list, you can have duplicate values, right? So if you were trying to keep track of how many times or the rolls of a die, if you rolled a 2, 5 times in a row, in a list, you could store that and it wouldn't be any problem. So even though the item 2 appears twice in this list, it's going to be stored twice in the list, and that's no problem. We'll see later another kind of data structure called a set, where you're not going to have duplicates, but in lists you can have duplicates, just like if you were listing things on paper, no problem. All right. Does an empty list mean infinite items? No, let's actually talk about the empty list real quick. And I think that's worth mentioning here. So empty just means there's nothing in the list yet, but you can imagine, so we start out, if I deleted what was the values I was initializing this list with, when I go to print out, well, what are the roles after appending one? Maybe I'll print this once before. So if we print roles once before appending and then once after appending, what you'll see is, initially the list is just empty. There's nothing in it. It's a blank slate, and then we can append new items to that list. I'm going to, for our purposes, keep a few items in this initial syntax, and for note purposes, I think this is valuable, just so you see that this is how you would initialize a list of integers. Just as we can append, we can also pop, right? So roles.pop is a method, and what that's going to do is pop or remove. And let's make a couple notes here. So append lists append method adds to the end of a list. All right, and pop, what it's going to do is lists pop method with no argument, right? So notice those empty parentheses following the method name, just like a function call, removes the last item of the list. All right. So what pop's going to do is remove the very last item. It's like you're popping it off the top, if you imagine these as stacked up on top of one another. And what we can do after this is print roles again, just to convince ourselves that, okay, so we rolled a 6 through this rand int that was appended. And then after we popped and we printed our list again, it's the exact same, right? I could also, roles pop one more time. And we could remove the last element once more, right? And so now our length would be 3 if we were to ask for the length of our string. All right. So one question that came back up is, can I explain what a literal is again? Sure. When we write a value directly into our programs, so like here I'm writing the number 2, here I'm writing the number 3. Those are integer literals because I'm literally saying this is the value I want you to use at this point. It's not like we're asking the user for some input or we're computing something specifically. No, this is the concrete value I want you to use. Similarly, with a list literal, we're saying, here's the whole list. Like this is a list that's going to have a length of 4. Its items are going to be 2, 3, 2, 6. And so this is a literal because we're able to specify a complete list in code and in syntax that's provided by the language. There's one other way of initializing lists we'll learn about later that wouldn't be considered a list literal. It would be considered a function call. And since we're on the subject, may as well. So let me just show you one other example here. So let's imagine we wanted a list of strings called words. So words is going to be a list of strings. We can construct a list, an empty list, using the list constructor. All right, so that's just a function, right? So just like we have functions for int and str, and we can construct and change types between them, we'll see better uses of list later. But if you just use the constructor like this, this allows us to set up a new list. And notice that's a function call. So that's different from a literal, even though you can make an empty list with either one. So just the same, we could say, words.append hello. And if I were to print the words list, we would see in our output, I've got a list with one string in it, which is the string hello. And so this is a good example of using lists of many different types in the same program. Right, so one question is, what's the difference between declaring and initializing? So this is a declaration where we're saying I'm declaring a variable named roles, and I'm declaring that its type is going to be a list of integers. Initialization is just the first time you assign to a variable. So the very first time it actually has a value associated with it, that's what we would consider initialization. So there's a question of what if pop does have an argument? Great question. So unlike unlike append that's adding to the end of a list, pop does allow you to remove a specific item from it. So let's give an example of this. So roles.pop, and let's say 0, and lists pop method with one argument pops a specific index, right? So this is going to remove the very first element or the very first index from our list. And it's going to cause everything to shift by 1 in the background. So we would still have things. So notice that my initial list was 23262. But after we popped index 0, we're starting with 2, right? So we popped the last 2 and the very first 2. So you can pop or remove very specific items from a list. We won't use that as frequently, and that's why I didn't mention it originally. What if you pop from an empty list? Great question. This is something that I would encourage you to try playing around with. So this will be the last quick demo on lists before we jump over to loops. But if I start up a REPL and I have an empty list, such as a list of integers, and let's say it's initialized as empty square brackets, and I say empty list.pop. You can't pop from an empty list. You get an index error. Similarly, if you try to say empty list index 10, you're going to also get an index error, slightly different message that the index is out of range. So if you try and carry out an operation on a list that isn't possible, you'll get an error like that. All right, so this is a quick introduction to lists, and fundamentally these are the things that we can do with them. We can declare them, we can initialize them with some values, we can access individual items, and actually we don't have an example of that here, so let's give an example of that. So maybe up after our very first print, the length of roles is length of roles print f. The last value in the list is, and then let's use our the expression we looked at in the very first slide of the day, which was roles of index length of roles -1. All right? So that's going to be the last value or last item in the list. And maybe I'll change value to item there. The last item of the list. And this is, of course, before we added that random integer, right? So if we wanted to just, convince ourselves that that will work, let me try this again. So Python m lessons list example. Oops. I think I'm in the wrong directory. Great. Python m lessons dot list example. And that's actually a good, I've seen some tickets in course care and in office hours where people get a module not found type of error. And often that means that for some reason, your terminal isn't operating in the directory you would expect. And one of the first things I would try is what I just did, which is close out with the trash can icon to kill the current terminal, start up a new one and try again, and often that'll fix it. So what we just added to our program here was the last item of the list is 6, which was the last item of our literal. And so the last thing that's worth mentioning and having in our notes here is that you can access items individually. All right. So those are some of the fundamental list operations. Now let's turn our eyes towards looking at loops, which are very exciting. All right. So I'm going to clear my Blackboard here, and let's think about loops. And I'll come back. There's a great question in Poll Everywhere about, can you sum those numbers? And yes, of course, we'll be doing tons of algorithms like summing and averaging and finding the most common and things like that as we move forward. But we actually need to learn a little bit about loops in order to do so. So loops are a control flow statement construct that allow us to have parts of our code repeat, or segments, blocks of our code repeat many times over. And you might think, well, how many times? And 10 times. If I'm a human and I'm asking you to do something like, tell me you love me 10 times, you might roll your eyes and say, okay, fine. But if I said, do that 1,000,000 times, you'd be like, yeah, no, I'm not. No, Chris, like, what are you? I'm not doing that. But pretty soon we'll see that we can write a computer program that can do something 1,000,000 times over without really batting an eye. In fact, that's sort of the magic and the intent of computation, being able to repeat algorithms and carry out algorithms over significant amounts of data. So we're going to look at a specific construct of a loop called a while loop. And let's talk about the syntax and the control flow of a while loop before we go and make some examples in code. So a while loop is a repeating control flow statement. Just like we saw if-then syntax, a while loop is a statement, just like an if-then statement, right? But there's a big difference. And the best way to think about that difference is with a flowchart. So imagine we've got some code and we reach a while loop, right? So I'm going to use blue here to signify a test condition. So this is our while loop. And just like with an if statement, there's some test condition. Right? And we're going to see that the while keyword is going to be followed by some test condition that's going to be a Boolean. And that's also worth noting here. Bool. Right? So if this test condition is true, because it's a Boolean, we know that it's going to, or a Boolean expression, it's going to have to either be true or false. And if it's true, what we're going to do is we're going to go into, maybe I'll use orange, the repeat block or the while loop body. The body block, right? So just like we've seen blocks of code with if statements that are all indented and at the same level of indentation, we're going to have another block of statements that are our while loop body, right? There's also a false condition, right? So the false condition is, okay, well, we're not going to go do that. If that test is false, we're just going to continue on in our code, right? So this is a lot like an if statement that doesn't have an else branch associated with it. So this is just like if something is not true, then continue on past the then block, right? But what is different and what is very magical and special and beautiful and awesome about a while loop is when this while loop body block, when it's done, when that last statement evaluates, what happens is not what you do with with an if-then statement. Like an if-then statement, you just continue on, right? Nope. With a loop, you're coming back to that test and you're testing that Boolean condition again. And if it's true, you're going to go back into the while loop repeat block again. And then you're going to go back and you're going to test that condition again. And so you notice that there's a loop. We're going to go back up to some point in our code and try the entire block again if that statement is true. And then once this test condition becomes false, that's when we're going to continue on just past it. All right, so let's look at the syntax for this, and then we'll try writing this out in VS Code. All right, so syntax is, we've got the while statement. So while, and then we're going to have our test condition. All right, I'm going to put this in blue, and I'm just using the greater than and less than symbol to say this is like a template. We're going to drop our Boolean condition. And here you wouldn't write the less than greater than symbol, right? So this might be while something is equal to true. Very similar format, exact same format as the if statement, except we're using the while keyword here. And then of course we're going to have our colon, and then inside we're going to have our our body. And so this will be indented. So the body is indented. All right. And so in the body, we can have statements. We can have if statements. We can have more while loops if we wanted. We can have function calls. Any statement we want, we can put inside the body. And that's a block. And then, there isn't anything special to say, hey, we've reached the end of the body, go back and test again. It's just whenever the last statement inside of the body of the block is evaluated, Python is automatically going to go back up and test that condition once more. So I might, just make a note that, back at the same level of indentation as the while, more code follows. All right. So if this test condition is true, we go into the body, we do whatever is specified there. So just like with an if statement, this test condition has to evaluate, and we're going to go in one of two directions. The key difference is, unlike an if statement, when that body is done evaluating, we're going to go back and evaluate our test condition one more time. So what I'd like to do is actually experiment with this in VS Code just a little bit to get a feel for this control flow statement. And then I'll take some questions. So let's go back and let's set up a new file. So I'm going to, in my lessons directory, set up another new file. And I'm going to name this, say, loop examples. All right. And let's just give ourselves some documentation here. Examples using loops. All right. So we've got this while keyword. You'll notice it's syntax highlighted in a special color because this is a built-in control flow statement, just like if. And let's maybe ask the user for some input. So we can have any Boolean expression we want here. So let's maybe ask, for the user, do you need more love? Yes or no? And another space, maybe a dash. So we know that when the user has a chance to enter their response after they're being asked this question, right? Now, that's not a Boolean expression, right? The input function returns a string, so we know that that's a string expression. So maybe we just ask if the user responds with yes, and we have a colon. So notice now we have a Boolean expression here. We're going to ask the user for some input that is a string. And if the string they give us is equal to yes, this will evaluate to true. And we're going to go into the repeat block, or the body block of the while loop is evaluated. And I'm going to make this a multi-line comment when the test expression is true. Okay. So what do we want to do? Well, maybe we'll just print, I love you. It's a nice little program. And then after the while loop completes, we'll print something like, have a lovely day. It's a beautiful day out there, by the way. After class, you should go out and get some sun. Right? Have a lovely day. So we've got a nice little example of a while loop. Right? Now, if this behaves as I told you, then after we print I love you, we expect to be asked that question again. We don't expect have a lovely day to be evaluated. So let's try running this program. And let me make sure I don't overwrite the code here. All right, so now I'm going to say Python. I want you to run the lessons.loop examples script. Do you need more love? Well, yes, computer, I would like some. And it tells me I love you. Right? Do you need more love? And notice, there it is. We've looped. And this is something that we haven't seen happen before in any program we've ever written. We've gone back up and we're testing this again. And we know that this is being evaluated again. We know that this function call is happening and we're waiting for the user to respond to it because that's where we're at in the program. And if the user responds yes, we're going to print I love you again. So yeah, I could use a little more love. Sure. Yeah, I could use some more love. Yeah. Okay, fine. I'm feeling well loved by my computer. And so notice that when I print no, or when I respond with no, this expression evaluates to false, and we continue on in our program to print have a lovely day, and our program has completed. All right. Thank you all for the love in the questions. I love you too. Is there any way to import random words instead of integers? Yeah, we can do we'll have a dictionary of words that we can use later in the semester, and we can do some cool stuff with setting up lists of words and choosing random words. Am I okay? Yeah, I'm good. I'm good. Let's see. If you used a function to loop, can you still claim credit for the loop portion of the rubric? If you use a function to loop and you implemented it with recursion, that's going to be a different concept than a loop. For the project, you're going to want to use a while loop and use this as part of your gameplay in some way. Typically, you would have a variable here. You wouldn't ask the user for input as part of this condition, but I wanted to use this as an example so that you had a chance to see that this expression gets evaluated each time the body block evaluates. So what if we wanted to count how many times the user had responded yes to this question? Let's set up a counting variable for that, right? So I'm going to set up a variable named count. It will be an integer and initially 0, right? Because before we count anything, we have 0 occurrences of this happening, right? So maybe after printing I love you, we want to increase count by 1. And here's where we see that relative reassignment operator coming into play. This is no different from writing count is assigned count plus 1, but here we're increasing count, by 1, right? That's great. Now, why don't we print, and we'll use another F string. So I'm going to use a format string here. Count is, and then the total count, right? So we've modified our program, right? We've added this counting variable, set it to 0 initially, but each time this loop is evaluated, each time it iterates, so to speak, we're increasing that variable by 1, right? And we should see that in the resulting output. So if I were to run this one more time, and oops, I didn't run my program. Actually, I'm going to scroll this down just a minute or just a bit. All right, so I'm going to run this again, and yes, 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 yes. And so notice each time this loop is evaluating, the value of that variable is increasing by 1 because that's what we're asking the program to do or commanding the program to do at this point. And so count is increasing, 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 right? So that's kind of neat. And this is going to turn out to be a very important idea with where we're going. The idea that we can increase or change some variable's value inside of a loop. Well, if we were to use this count to access the indices of a list, we'll be able to access each item in a list no matter how long it is, right? And so that's what we're going to try and do next. But let me take a look at the questions that came in. Computer love greater than human love. Oh, you don't even know. We're going to see an even better example of it here shortly. don't we say, would this be a variable, a global variable, count? Yes. So because count here is defined and declared outside of any function, this would be technically considered a global variable. I'm only using globals and not wrapping these in functions so that we have less to type and our examples are a little bit more pure. But for a well-designed program, this should all be within the context of functions, right? And you can use while loops inside of functions, no problem. All right. So what if we wanted to make a loop that ran a specific number of times? So this is an example that the user is telling us yes or no whether they want the loop to continue and repeat, but that's kind of slow. I have to type out yes or no. What if we wanted to loop a specific number of times as fast as the computer could do it? Well, we're going to see a pattern for doing this where we have a counting variable, and we're going to use this a little bit differently than this count. All right. So let's talk about a pattern that we'll use to iterate a specific number of times. Right. So the idea of iterating is, a lot like you're probably used to hearing it in a design context where, okay, you try something and then you improve it or you make forward progress and you're iterating towards some goal. You're making progress. All right. So here we're trying to iterate through write a loop that iterates a specific number of times and brings us closer to that loop being completed. Well, common variable name that you'll see in programs that have loops and iteration is this variable I. Now, we tell you choose good variable names and meaningful variable names. An exception to that rule is this I variable. It's such a classic and historical variable name that any programmer who sees I in a context like we're about to knows that you're using that to be short for index effectively. So I is typically short for index, right? So what we're going to do is use this index to count from 0 all the way up to some specific number of times. Or let's set up a variable iterations. And let's say we wanted this to iterate 10 times over. All right. I'm going to set up a variable named iterations and assign it 10. So what's the pattern for defining and declaring a while loop that will do this, that will iterate this many times over? Well, we can say while and I is less than iterations. I'm going to come back and talk about that in just a moment, but that's probably going to feel a little bit weird and unnatural. Why are we saying, well, I is less than the number of iterations? Well, again, it has to do with starting from 0, right? So if we start from 0 and we want to loop 10 times, the last time we iterate, I's value will be 9. Okay. So what do we want to do here? Well, let's print I love you some more, right? I love you. And maybe let's use an F string here or a format string. And we'll just say, I is I, right? Now there's something else very important we need to do here before we go and run this program. In fact, I'm going to run this program, but please let me get big here for a second. Don't run this program quite yet. This is what we call an infinite loop. This loop will not end unless we forcefully quit our terminal and tell it to. So let's try it, right? And I'll try it, but you don't need to do this, right? So Python m lessons.loop example, right? Do I need more love? No. And it's going to ignore me. It's going to give me so much love, right? Infinite love. And what you can't really see it. It's kind of flickering, but this is printing I love you as many times as it can. If you find yourself accidentally writing an infinite loop, which is what we call this, it's okay. You've got two options here. The easiest option is just use the trash can. You want to use the trash can to kill this, that's totally fine. Or if you can remember it, Control-C is what I just pressed on my keyboard. So Control-C will quit an infinite loop or interrupt an infinite loop to stop it. Otherwise, it's just going to keep looping as quickly and as fast as it can, which is, it's kind of cute of the computer telling me it loves me, an infinite number of times. But if you're on your laptop, that will drain your battery. Your laptop will get hot. Your fans will start going. You don't want that. So what's wrong with this loop? Well, notice that this condition never becomes false. And in order to have a valid loop, we need to be making sure that each time our loop iterates, we're moving closer and closer to our condition becoming false. So we need to increment I by 1. So I plus equal 1, right? And so this is our common pattern. And I'm going to try running this one more time. Do I need more love? No. And notice that the computer here printed, I love you. And then it did it 10 times. I can't even scroll up. All right, I'm going to have to hide my code here for just a second, but yeah, no. And if I were to scroll up just a touch, there it goes, from 0 all the way down to 9, right? I mentioned that like computers are happy to do things that humans would balk at, right? I asked you if you would tell me you love me a million times and you said no. But if I asked the computer to, our program now with changing a single value in it is very happy to print as many times as it can, or as many times as we're asking it, I love you. And so that's kind of neat. That's kind of cute, computer, for telling me 45,000 times. I think that's probably more than my mom's told me. Don't tell her that, but it's true. And so this is why loops are so powerful. One of the things that is shocking is that most of the time that this loop is spending, it's actually spending it printing. The computer could loop much faster than that if it didn't have to print out each line here. So I want to give you one more quick demo and then I'll take to questions. If we were to print only when I was equally divisible by, say, 1,000, and I'm going to indent my print statement. So notice this is an important characteristic of while loops and if statements. We can nest other kinds of statements within them. So it's no problem to have an if statement inside of a while statement. But notice that this logic is, well, this loop is going to be evaluated for every I, and each time outside of this. And notice it's important that this increment is not in the if statement, right? So we want to be sure that I is increasing each time. But what we're saying here is only print I love you when I is evenly divisible. And I forgot my equal symbol. My equality check. When I is evenly divisible by 1,000, that's when we'll print I love you, right? So we take the remainder of dividing I by 1,000. And if that remainder is equal to 0, then we'll print this, right? Now let's try, let's see if we can get the computer to count to 1,000,000. Before it didn't quite get there, right? We got to 100,000. But what I wanted to impress upon you is that most of the time that the computer was working on that, it was spending a lot of time trying to get it to show up on the screen. So if we ask it not to show up so much on the screen, and we only print every 1,000, boom. That program just went through 1,000,000 iterations of this while loop. This code that we wrote together in the past 3 minutes just evaluated 1,000,000 times over. The computer checked 1,000,000 different times. It did a remainder on 1,000,000 different values of I, whether or not it's equal to 1,000. And only every 1,000 tries did it go and print that out. And look at how fast that is. That's incredible, right? So this is really what the superpower of computing winds up being all about, this ability to specify little algorithms. So this is, a very simple, teensy, silly algorithm, but an algorithm nonetheless that's running 1,000,000 times over, faster than we as humans could do this 10 times over, or even a few times over. All right. So if you tried the infinite loop on your computer, hopefully you were able to get it to stop with that trash can. The trash can will stop it. We'll come back and we'll talk about recursion later this semester. Recursion is something that we don't really have a good frame of reference for yet, but they're related to one another. But I don't want to get too into the weeds there. Come to tutoring if you want to talk a little bit more about that. Can you embed multiple while loops? Yes, you can have while loops within while loops, and we'll see some algorithms that do that. For now, we're probably going to have mostly loops that are not nested within one another, but we will see examples of that because it's important to understand how that works. That's something I would encourage playing around with and convincing yourself that you understand how it's being evaluated. Does the program now ignore the first loop? No. So the first loop, if I were to run this one more time, I was just very quickly responding with no. But if I said yes, 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 so that first part is still running, and we're not going to continue on to the second loop structure until I say no to the first one, and that first loop exits, right? And so boom, there we go, and then our program's done. All right. So we're not going to quite get to be able to integrate loops and lists today, right? But hopefully what you can imagine is if within a while loop like this, let's imagine, actually, let's make a quick example here. I won't, this is totally fine to wait until the next lesson to go through. But imagine we had something like print and then words, and we had a dictionary, and number of iterations was the number of words we had in that dictionary. This would be a while loop that could print every word in our dictionary. And so this idea of combining the subscription notation of accessing items in a list using their index and the ability to have a loop where we can increment that index one by one by one is what brings these two concepts, sort of in lockstep with one another. We can write a loop that starts from index 0 and moves our way through each item of a list one by one by one. And if we base our Boolean expression on the length of our list, then we'll be able to write a while loop that operates on an arbitrarily long lists of data. And we'll spend a lot of time with this concept because this is sort of the bread and butter of data processing in a computer program. So it's 4:45. That's the end of our official lecture period. Great work today. If you had questions, if some of your software didn't work for some reason, please stop by tutoring tonight and we can work with you one-on-one there. And otherwise, just as we've been doing, as if you were coming up to me in lecture after class, I'm happy to take a few more questions on Poll Everywhere, but by no means are you required to stick around for this. So great work moving through today's topics, and we'll get more practice with this. We'll have some asynchronous content on Thursday to look out for. And there are a few questions that are just sort of general understanding questions based on what we did in class today on Gradescope. Otherwise, get outside. It's beautiful out, and have a great rest of your Tuesday. All right, so there's a question of what's the point of a loop if it's going to ask the same thing over and over again? So that's a fair question. This is a pretty silly loop. It's asking the same question and it's doing the same thing inside of it. This is really, it's sort of simplistic to try and give a sense of very step-by-step exactly how the loop is evaluated. However, most loops won't be asking you a question each time you loop through them, although some loops do. If you've ever played a game where you run out of lives and you ask, do you want to play again? And it says yes, like that. There's a loop that's happening in that. It's called a game loop. Very similar to the one that you might have in your project. If you want to give someone using your project the ability to play a game multiple times over, loops are commonly useful for that. Where they're more common though, in what we'll see more of this semester, is when we want to, we've got 100,000 pieces of data in a list, and we want to loop through or process 100,000 different pieces of data and carry out some computations on them. Maybe we want to add all those numbers up. Maybe we want to average them or find the standard deviation. We're going to have to loop through each of those items. And so the work that we do inside of a loop will be different for each item that we're processing in a list. We didn't get to bring those two concepts together today, but we'll be seeing that very soon. Are while loops functions? That's an interesting question. No, while loops are not considered functions. And the reason is think of them more like if statements. So if statements are just what we call a control flow structure. The Python language reaches an if statement and it makes a decision on how to go in one way or another. Very similarly, when we reach a while statement, the computer is going to decide if this is true, well, I'm going to go into the loop. If this expression is false, I'm going to skip right past it and continue on in the program. So we call these control flow statements. It is different from a normal statement because it's not a guarantee which direction you're going to go next. We don't know until this statement or until this expression is evaluated, whether or not we're going to go into the loop again or for the first time or skip past it entirely. Can you briefly talk about how to keep a loop from being infinite? This is a great question. So how do we keep a loop from being infinite? First, we need some kind of condition. And inside of that loop, something needs to be changing that's bringing us closer towards that condition becoming false, right? So if we think about, I is initially 0 and iterations initially, 1 million, if we didn't have line 18 here, if we didn't increment I, if we didn't change anything about I or iterations inside of the body of this loop, it would be an infinite loop, right? But the way that we make progress while we're evaluating a loop is by changing one of the variables or some state in our program that's ultimately going to make this expression become false. That's typically how you avoid an infinite loop. Now, I should mention that the very first loop that we wrote, that condition, what was changing was what the user was giving us as part of this expression. Typically, you won't see something like this. This was sort of let's just show a quick demonstration that this whole expression has to be evaluated each time. So each time this loops, we're going to evaluate whether or not this is true or false, and we have to evaluate this expression from scratch each time. But typically you're changing a variable, and that variable is a part of the test, and we're making progress, right? So if we start at 0 and we add our way up, we're getting closer and closer to 0 being 1,000,000, right? If I had subtracted 1 here, we would have had we would have still had an infinite loop, right? Because we're moving further and further away from this condition ultimately being false. We'll spend some more time with some best practices on loop termination conditions and things like that as we move forward. So if you don't go into, there's a great question here on this first while loop. If we don't go into this, does that mean that count stays at 0? Yes, but we could prove that to ourselves by saying print count, and actually let me use another format string. One of the things you'll quickly realize is that format strings are much nicer than concatenation. So let's print count after the loop completes, right? So if I run this again, do you need more love? And I'm going to press no or enter no so that this loop never evaluates. We don't go into the repeat block. Oh, and I printed out I love you a lot of times. Let me make this iterations 0 so we never actually go into that while loop, and we'll be able to see it. No. And one of my complaints about VS Code is the scrolling and the terminal is not very good. So notice, here we go. Count after the loop completes 0, right? So if we don't go into that loop, if this is initially false, the first time this evaluates, there's no guarantee that you go into a while loop even once. This test has to be true each time the while loop body is evaluated. So if it's never true, as it was in this evaluation, then we'll just continue right on, and yeah, count remained at 0. Is string actually a list of characters, or is it a different animal? I love this question. It is a different animal, but not by a whole lot. One of the key differences between a string and a list is that you can't actually change a string after it's constructed. You can only make new different strings from it. We don't have a good reason for navigating the nuances of that quite yet. We'll get there in the next week or so. But the idea is when you're concatenating two strings together, you're actually generating a whole new string that isn't either of the first two. It's just taking those values and copying them to a new string, one followed by the other. With lists, we actually can remove and add items to it and from it. So with strings, once you have a string, you can't remove letters from it or add letters to it. You could only concatenate or generate new strings. And so whereas a list is something we'll come to learn is mutable, meaning we can change it, A string is something that is immutable after its initial construction and you can't change it. But that's a little bit more nuanced than we need to know right now. They are very similar, and in some languages they are the same, but not in Python or in most very popular languages. Strings are so commonly used and special that they get their own sort of custom features to make them highly performant and much more suited for the types of tasks people use strings for versus lists for. If a variable is declared in the main function, is it global? Or does it have to be outside of any function? This is a great question. So a global variable means it's defined outside of any other function's body. So a global variable would be outside of main. If you define a variable inside of main, that's going to make it local to the main function. Main isn't any different or any more special from any other function other than some convention that we've sort of decided completely separate from what Python cares about, that we're going to call it main. It's really just any other function, the same as any other function. Is there a way to base an if-then on the amount of times a while loop is I love this question. So like if the question is, if a user says yes 3 times and they print wow, like maybe you should talk to a human rather than your computer. And yeah, let's go ahead and implement this question, and we'll call that our last example of this question series. So we could have an if statement like if count is greater than 3. Then we could say something like, print, wow, you need a lot of love. If we wanted to make this a very positive program, maybe we would say, wow, I really, truly, deeply love you. Right? A little bit more positive vibes here. And so if we were to try and run this, sure enough, like just like any other logic, the computer is going to do exactly, or Python's going to follow our instructions exactly. So do you need more love? Yes. I love you, count as 1. Do you need more love? Yes. Count as 2. Do you need more love? Yes. Count as 3. Notice this condition is count greater than 3. So on this very next iteration, we expect to get our new message, and count is 4. And then, wow, I really, truly, deeply love you, right? So yeah, what we're going to see is loops become much more interesting and powerful. And where we start to develop algorithms is by having conditionals inside of our loops that behave in certain ways. And so this is an example of that, that we have some special behavior that only starts to take place after some specific number of iterations. These are great questions today. I really appreciate that. If you have further questions, do come by tutoring tonight. These two concepts, we're going to get a lot of practice with in the next exercise and over the next couple of weeks. And really, they're the bread and butter of writing computer algorithms. So great work following along today. And yeah, seriously, go get outside. It's a beautiful day out there, and have a lovely rest of your Tuesday.